In this video I'm going to show you how to determine the empirical formula for a compound if you're given information about the relative abundance of the elements in that compound. So in this example, it says the compound's been decomposed and it's made up of carbon, hydrogen, and fluorine, and you get the amounts that are shown here, and the amounts that are shown are given in grams. Okay, so what we've got to do here is we've got to actually figure out what the formula is, and the formula is basically just the molar ratio. So the empirical formula is just the molar ratio, the ratio of all the different elements, and it's expressed in the lowest whole number ratio. Okay, so we've got to, first of all then, since we're trying to get to a molar ratio, we've got to convert these grams. So these are basically the relative abundances or the ratios given in grams, and we've got to convert that to moles so that we can figure out what the formula is. So to do that, we've got to multiply to moles. Alright, so there's our basic problem. So all we've got to do is convert these grams of carbon into moles of carbon. So we're going to multiply by a conversion factor that defines what the molar ratio, or no, defines what the molar mass of carbon is. And that's just going to be 1 mole divided by 12.01 grams of carbon. That's sort of the definition of the molar mass of carbon, is 12.01 grams per mole, or 1 mole per 12.01 grams. And when we do that math and multiply that out, we get that is equal to 3.45 moles of carbon. Alright, now we're going to do that the same thing for hydrogen, and for hydrogen it's going to be really close to that number of grams since the molar mass of hydrogen is so close. So we've got, it's going to be 1 mole, it didn't have to be 1.0 moles, but it's going to be 1 mole divided by 1.01 grams of hydrogen. Okay, when you do that math, the 7.83 times 1 over 1.01 grams, then you get 7.75 moles of hydrogen. Okay, and then finally, when you do the same thing for fluorine, and you multiply that by the molar mass, that's 1 mole over 19.0, you will get an answer of 0.86 moles of fluorine. Okay, now we've got the molar amounts in the original sample. So in the original sample was somewhere around 65.66 if you add up all these masses over here. But anyway, this just basically tells us how many moles of each one of these elements was in that compound that got decomposed. So now what we got to do is we got to figure out what the whole number ratio of these is. And the easiest way to do that, at least to try, in most cases it'll work, is you want to take the smallest one, which is this 0.86, which is for fluorine, and divide divide the other molar amounts by that number. So if we take 3.45 moles, and this is for carbon, and divide it by that 0.86 moles, which was the fluorine, we will get about 4, roughly 4. Okay, and then if we do the same thing for the 7.75 moles of hydrogen, divide that by 0.86, we'll get a number that's about 9. And then finally, if we do the same thing over here, well, for the fluorine, which is just 0.86 over 0.86, you're going to get 1, obviously. So that is the molar ratio, and that's the simplest form. You can't really simplify that down, especially since you've got this 1 here. So that means that the empirical formula for this compound is going to be C4H9F1. So I'll just leave it as F. So that's how you do that, and basically do it any kind of problem like that. So I hope that helps.